We now go to examples. We have 4 examples before us. The one says to establish the equivalence of the term you see on the left and the term you see on the right. That is, P if and only if Q in bracket, negation of it all. Okay, that we want to show if it's equivalent to P if and only if negation Q. Okay, the second example says we should show that these 3 statements, X or open bracket X if Y or implies Y, close bracket, or Z is a tautology. Okay, the third one says we should construct a truth table for what you see there. And the fourth one says we should determine the contrapositive of each of the following statements. You now know what contrapositive is. If you don't know, rewind the video back to where the definitions for converse, inverse, and contrapositive is. It has to do with the conditional statement. Let's go into the solution of the examples. Solution to 1 says establish the equivalence of to the negation of open bracket P if and only if Q close bracket, and show that it is equivalent to P if and only if negation Q. So the 3 lines you see in between the 2 statements is just saying equivalence. Okay, so all you need to do is to find, so what do we need? We need P, we need Q, we need negation Q, we need P if and only if Q, the biconditional statement. We then need negation P if and only if Q. We need P if and only if negation Q. So we have how many columns? 1, 2, 3, 4, 5, 6 of them. So we have P, Q, negation Q, P if and only if Q, negation P if and only if Q, all in bracket, and P if and only if negation Q. So how many statements do we have? Clearly we have 2, P and Q. So if we have P and Q, we have 4 entries for our column. Is that not so? So under P we have T, T, F, F. Under Q we have T, F, T, F. Negation of Q, what's that? It's the opposite of everything you see under Q. So definitely wherever there's T, you have F. Wherever there's F, you have T. Wherever you have T, you have F. Wherever you have F, you have T, which is what you see under negation Q. For the 4th column, we have if and only if. Now you know what we're looking for. For if and only if, whatever you see under P must be the same under what you see under Q for it to be true. Is that not so? Else everything is false. So let's check now. We need P if and only if Q. Under P we have T, under Q we have T, the same. So the first entry under P if and only if Q must be T. Under P again for the 3rd row is T, under Q is F. So we have T, F. What do you expect to have under P if and only if Q? You should have F, because they're 2 different things. Under P we have F for the 4th row, and under Q we have T for the 4th row. So F and T, 2 different things, definitely F. And for the last row of P and Q we have F, F. So definitely we expect T, because all conditional statements will always have T. Now that we have P if and only if Q, which is our 4th column, we're looking at the 5th column. For the 5th column, we have T wherever there's P if and only if Q, but we're looking for the negation of it. So it becomes F. We have F for the 3rd column, the negation, which is T. We have F for the 4th column and the 4th row. F becomes T, and the last one is T, and it becomes F. Okay. Now we want to find out if they're equivalent. Is that not so? So we need to look for P if and only if negation Q. Okay. So under the 6th column is what we're looking. We want to verify the entry. So P and negation Q is what we're looking at. So under P we have T, under negation Q we have F. They're different. T and F different, so definitely we will get F. Is that not so? For the next entry, which is the 3rd row, we have T and T. They're the same, so we have T. For the 4th row, P and Q, we have F. Sorry, P and negation Q, we have F, and F, they are the same, so we have T. For the very last row, under P and negation Q, we have F and T. They're different, so we have F. Finally, we can see that the 2 entries are exactly the same, so they are equivalent. So you can conclude that the the relationship is equivalent. Solution 2. So we have to show that what you see on the screen, that x or x implies y or bracket or z is a tautology. You know what a tautology means, that everything you get at the final entry of the truth table is true or true. Okay, we have three statements because there's x, there's y, and there's z. So we need x, we need y, we need z. So board maths, we go into the inner bracket, is that not so? So we have x implies y, we need x implies y. Thereafter we need x or open bracket x implies y, close bracket. And finally we need everything, which is the last column you see there. Okay, so back to the screen. Under x, because we have three statements, your entry will no longer be TTFF. It will now become TTTT FFFF. That's 8 entries. Okay, so 4 T's and then 4 F's. Okay, not 2 T's and 2 F's. Not so. Okay, if you do that, you'll be wrong. Okay, under Y now, you want to have TTFF, TTFF. You need to know this. Okay, and finally on the Z, you have TF, 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 TF. Okay, note this. 8 entries in this order. So if I haven't typed in your PQR, just replace X, Y, and Z by PQR. That's all. The entries remain the same. You have to be careful. Many students make that mistake. Okay, so now we need X implies Y. How do we find X implies Y? That means X is pointing to Y. So we go to the entries of X and Y. So under X we have T, and under Y we have T. So T is pointing to T, it will give us T. Again, X is pointing to Y, we have T and T again. T is pointing to T, you'll get T. Again, under X we have T and F. T is pointing to F. What should you get for your truth table when X is pointing to Y? Clearly, because T is pointing to F, you will get F. Again, T is pointing to F for the next row. Again, you'll get F. So you can verify each and every one of them for X implies Y. The next column, which is our fifth column, says X or X implies Y. So we have X implies Y on our fourth column, entries gotten already, and we're looking for X or X implies Y. Remember, for or, the only time you get F is when both ends are F. Both entries under P and Q are F. Is that not so? So let's see X or Y. X entry has T, 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 F, F, F. X implies Y entry has T, T, F, F, T, 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 T. Okay? So X or X implies Y. So T or T, definitely that'll be T. T or T again, we have T. T or F, remember, it doesn't matter, you will still get T or F, T or F. We should get T again there. Okay, so something is wrong here, you should get T here. So you can verify and correct whatever mistakes I have here. You yourself sit down, check your table, and we can discuss it in the next video. Okay, so in our class or during our question sessions. Okay. And finally, we're to construct the truth table of what you see there. Again, P and Q everywhere. No, there are no 3 of them. So you put in all the things you need. You need P, you need Q, you need P, you need negation P, you need negation Q, you need P implies, you need negation P implies negation Q, you need negation P if and only if Q, you need P or negation Q, then you need the other bracket, negation P cap, open bracket, negation P implies negation Q, and then you need open bracket, the second half of it, that's negation P if and only if Q, close bracket, if and only if, open bracket, P or negation Q, close bracket, and bracket. So there are 2 terms before the and between them. And finally, you have the entire thing on the last column. Okay, so you can practice, pause the screen, try all of this, and verify that your values tally with mine. And finally, solution to number 4. we're told to determine the contrapositive of each of the following statements. And we're looking at the first one. It says, if Julius is a banker, then he's rich. If Julius is a banker, then he's rich. Clearly, this is an if-then condition. That's what we have before us. So we can set P to be Julius is a banker and set Q to be he's rich. Okay, so we know that simply we have P implies Q. Okay, it's an if then. So you can check the previous video. You can rewind and go back to where I had explained the different grammatical ways of explaining or saying P implies Q. Okay, so we seek the contrapositive. That's what we want. And contrapositive statement means if you have P implies Q, we're looking for negation Q implies negation P. Okay, so we have said that P is Julius is a banker. So what do you think negation Q would be? Well, it simply is either you say it is false that he's rich, or simply just say he's not rich. Okay, and we said that Q is he's rich. So what's negation P? Either we say it is false that Julius is a banker, or simply just say Julius is not a banker. So what's the contrapositive? You just combine the two together. Okay, if Julius is not a banker, then he is not rich. And that's all. You're just simply going to give me the statement, if Julius is not a banker, then he is not rich. Therefore, the contrapositive of if Julius is a banker, then he is rich, is if Julius is not a banker, then he is rich. And that's all to that. And for the last solution for II, we're trying to find contrapositive again. It says, it is necessary to eat in order for Simi to be healthy. Wow. Can you see this necessary part of it? If you go back, rewind, you will see that it's similar to Q is a necessary condition for P. Okay, so what do we do here? We just simply let Q to eat and let P be Simi to be healthy. Okay, so our connective again is that arrow. Okay, so we seek the contrapositive. Contrapositive means we're looking for negation Q implies negation P. And also, so hence what do we do? Negation Q. We know Q is to eat. What's negation Q? Not to eat is a necessary condition. And what is a negation P? Simi needs not to be healthy. So if you combine the two of them together, what you get as our contrapositive sentence is simply not to eat is a necessary condition for Simi not to be healthy. And we're done with our video for chapter 1. So go through the video slowly. You can pause and study and practice along the way.